Hey, this is Check This Out Mathematics. I'm Mr. Donald, and we are currently doing a series of videos on logarithms. These are lessons on logarithms. And so in the first video, we answered the question, what is a logarithm? Okay, and we have this overall property between exponents and logarithms. The logarithm is asking what is the base? What power of the base gives us x? What power of the base gives us the argument x? And since b to the n is x, then the log base b of x is n. What power of b gives us x? The n power of b is x. So therefore, the log base b of x is n. Okay. And so now, we did a whole bunch of examples with that idea. And now, let's understand that a logarithm is an exponent. It's the most important idea. A logarithm, the log base b of x, a logarithm is an exponent. Here, n is the exponent. b is raised to the exponent of n. n is the exponent. And the logarithm is asking, what is the power that makes b become x? And it's the n power of b that becomes x. And so since n is exponent here, n is the exponent here, and this log base b of x is an exponent. So these are all exponents. The n, and the log base b of x. Those are all exponents. This is an exponent here, n, and n stays the exponent. And therefore, since n is equal to this logarithmic expression, then the log base b of x is an exponent. Okay? And one other thing you want to notice is this idea of a round trip. A round trip. Okay, so here we are at the logarithmic equation, and we have reached our destination here. And so, what is it that takes us back to where we came from? Well, it's a round trip. You know, if you go on a round trip on an airplane, you go to your destination, and then you go back home. Okay, all right. And so here we're going to make this round trip. We're going to say log base b of x equals n, and we're going to go from b around to n and back to x. And that takes us back to the original statement here. b to the n is x. That's our round trip. And so when you make that round trip, b to the n equals x, then you're back here, b to the n equals x. That's your round trip. Okay. Round trip. Okay. All right. So now, let's remember our properties of exponents. Properties of exponents. Okay. First property. when we have b to the n, that means b multiplied by itself n times. Okay, when we say b to the n, that means to take b and multiply it by itself n times. That's what an exponent is. Instead of writing b times b times b times b times b, we'll just say b to that n power, however many times we had to multiply it. Okay, and so with that in mind, b to the first is b. B to the first is b. Okay. Now, if b to the n is telling us to multiply b by itself n times, well then we can have the opposite of n, and so that would be b to the opposite of n, b to the opposite of n, and that would tell us to do the opposite of multiplication. So n is telling us to take b and multiply it by itself n times. And therefore, the opposite of n is telling us to take b and divide it that many times. And so we get 1 over b times 1 over b times 1 over b times 1 over b n times. Okay? B to the negative n, well, that's negative n is the opposite of positive n here. Okay? And so b to the positive n is saying multiply b times itself n times. And b to the negative n is telling us to divide by b n times. Okay? And so another way to write that is to say that we have 1 over b n times. Okay? So when we have 1 over b n times, that is saying to take 1 over b and multiply it by itself n times. Okay? 1 over b to the nth power here tells us to multiply 1 over b by itself n times. And so when we have b to the negative n, that's 1 over b multiplied by itself n times. Okay? A negative power is telling us to divide, and a positive power is telling us to multiply. Okay. And so now, one other thing that we want to make clear is that when we have 1 to the n, well, that's just 1. Okay? And so another way of writing this is just to say that 1 over b to the n is the same as 1 over b to the n like that. Okay? So the negative is telling us to divide. So we, instead of multiplying by b, we divided by b. And so that's the definition of the negative exponent. And so Since we applied that definition, we just go back to a positive exponent. And here, 1 to the n, and here we have 1 to the n and b to the n. So here I have b to the n, and 1 to the n just means 1 times 1 times 1, which will be 1. Okay? So that's the idea of a negative exponent. Okay? We don't want to think that a negative exponent makes things negative. Exponents do not have that power to make things negative. That's not in their power. Exponents can't do. But it is in their power. Exponents, what is in an exponent's power is to make things divide. Okay? All right? And so that's the meaning of a negative exponent. All right then. Okay. So we have b to the n means multiply b times itself n times. And this b to the first is just b. And then when we have b to the negative n, well then that means to divide by b n times. Okay? And so the negative is actually making this 1 over b. That's the inverse of b. Inverse means to flip it. Okay, instead of b over 1, we made 1 over b. So we flipped it, and then we can multiply. Okay, and so now then, we can say that b to the negative 1 is 1 over b. Okay, so b to the first is b, and switch hands here. Okay, b to the first is b, and b to the negative 1, b to the 1 power is b, and b to the negative 1 power is 1 over b. Okay, exponents have the power to multiply or the power to divide. That's what exponents do. They have the power to multiply or to divide. Okay, they don't have the power to make things negative. Okay. All right. So and then we can also say here that b to the negative n is 1 over b to the n. Okay? So b to the negative 1 is 1 over b, and b to the negative n is 1 over b to the n. Okay? Just some simplifications of the concepts we've been talking about. All right. Now, here's another interesting property. We have b to the 0. What is b to the 0? I mean, who raises something to the 0 power? I mean, what is that? Well, b to the 0 is 1. B to the 0 is 1. Okay? All right, well now, Mr. O'Donnell. That's just too weird for me. Well, let's see, how can we explain that? All right, so if we have b over b, that's 1, right? Yeah. Because when you can change this into 1 times b is b. Okay? What's b divided by b? Well, it's 1. And that's because 1 times b is b. All right. And so now let's remember this other property of exponents here. Do you remember this idea that when we had b to the first and b to the first here, and when you divide, you subtract the exponents. When you divide, you subtract the exponents. When you divide, you subtract the exponents. And so that gives us b to the 0, and that's 1. See, these are b divided by b is 1. And so then when you say you have exponents here, when you divide, you subtract the exponents. And 1 minus 1 is 0. Okay, and then, for that matter, if you have b to the third over b to the third, well, that's 1. You might remember that the same over the same is always 1. And so what's happening there is that we are subtracting our exponents. Okay, when we divide, we subtract the exponents. 3 minus 3, well, that's 0. And since b to the third divided by b to the third is 1, and when we subtract our exponents, we get 0, well, then b to the 0 must also be 1. Okay, another idea that's happening there is this one. Okay, let's check this out. If we have 2 to the third is 8, right? And now 2 to the second is 4. And 2 to the first is 2. Okay, so as we go up in the powers, we multiply by another 2. As we go up in the powers, 2 to the first is 2, and now to the second means we need another 2. Okay, so 2 times 2 is 4. 2 to the second is 4. And when we have 2 to the third, we need 3 2's. 1, 2, 3 2's. So 2 times 2 is 4, and 4 times 2 is 8. And so when we go up in the powers, we go up in the multiplication of the number 2 here. And so now, this is true when we go down in the powers. Okay. Okay, so here we are at 2 to the third, and if we want to go down a power to 2 to the second, well, we're going to divide by 2. You see, that's what exponents do. They're involved in multiplication and division. Okay, so 2 to the third is 8, and we want 1 less 2. We want 2 2's rather than 3 2's. And so we divide by 2. We take a 2 away. And so 8 divided by 2 is 4. We divide out a 2. And we're down to 4. And now here we have 2 2's giving us 4. And we don't want 2 2's. We just want 1 2. So we're going to divide out a 2. Divide out a 2. And so 4 divided by 2 is 2. And now let's continue that pattern. Let's divide by 2. So if we are at 2 to the third and we want to go down to 2 to the second, we take 8 which is 2 to the third, and we divide by 2 and we get 4. And if we want to go down a power, well, we divide by another 2. 4 divided by 2 is 2. And if I want to go down to the power not of 3, not of 2, not of 1, but the power of 0. The power of 0. The power of 0. Well, what happens when we take 2 and we divide it by 2? Oh, hey, that's 1. All right. 1. Okay, so 2 to the third is 8. If we drop down a power, we divide by 2 and we get 4. All right, 2 to the second is 4. If we drop down another power, then we divide by another 2. 4 divided by 2 is 2. And if we drop down another power from 1 to 0, well, then we divide by 2. 2 divided by 2 is 1. And that's what 2 to the 0 is. Okay, and so 2 to the 0 is the bridge that completes the rest of the idea here. Because what is 2 to the negative 1? Okay, 2 to the negative 1. Well, let's keep going on in this pattern by dividing by 2. Okay, so what's 1 divided by 2? Well, that's a half. So you see what a negative exponent does? It makes a fraction. That's within the power of exponents. Exponents have the power to make fractions. Okay, so 2 to the third is 8. 8 divided by 2 is 4. So 2 to the second is 4. 4 divided by 2 is 2. So 2 to the first is 2. 2 divided by 2 is 1. So 2 to the 0 is 1. And 1 divided by 2 is a half. And so 2 to the negative 1 is a half. All right? And then if we have 2 to the negative 2, well, let's divide by 2 again. And isn't dividing by 2 the same as taking a half? Dividing by 2 is the same as taking a half. And so half of a half is a fourth. A fourth. Okay. All right. And so do you know what 2 to the negative 3 is? Can you look at this and think about that? Okay, let's try it out. So 2 to the third is 8. 2 to the second is 4. 2 to the first is 2. And each time we're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. And we divide by 2. 2 divided by 2 is 1. And so that's 2 to the 0. And then we divide by 2 again. And that's what 2 to the negative 1. It's 1 over 2, a half. Okay, so here's the bridge. 2 to the 0 is 1. 2 to the first is 2. And 2 to the negative 1 is a half. 1 over 2. Okay, and then 2 to the negative 2 is a fourth. And 2 to the negative 3 is an eighth. Okay, so check that out. Check this out. 2 to the third is 8. 8 divided by 2 is 4. So 2 to the second is 4. 4 divided by 2 is 2. And so 2 to the first is 2. 2 divided by 2 is 1. So 2 to the 0 is 1. 1 divided by 2 is a half. And so 2 to the negative 1 is a half. And when you take a half of a half, you get a fourth. And so that's what we've been doing all this long. We took half of 8 and got 4. Half of 4 and got 2. Half of 2 and got 1. Half of 1 and got 1/2. Half of a half, that's a fourth. And that's what 2 to the negative 2 is. So 2 to the negative 2 is 1/4. 2 to the positive 2 is 4. These are inverses of each other. 2 to the second is 4. And the inverse, 2 to the negative 2, is the inverse of 4, which is 1/4. And then what's half of a fourth? Well, that's an eighth. Okay? Slice a pizza one time, you get half of a pizza. Slice the pizza 2 times, you get fourths. Slice the pizza 3 times, and you get eighths. Right? Okay. 2 to the negative 3 is an eighth. Okay? And so notice what's happening here is we get 2 to the negative 2 is 1 over 2 squared. And 2 to the negative 1 is 1 over 2 to the first. And 2 to the negative 3 is 1 over 2 to the third. Okay? So when we have a negative exponent, that means it just drops down. Okay? Negative exponent, it drops down to the denominator. Negative 3 as the exponent drops down to the denominator. And so 2 to the negative 3 is 1 over 2 to the third, which is an eighth. That's how it works. Good stuff. All right. All right, let's, we're having too much fun, time flies, okay? But let's cut this out here. Check this out, Mathematics by Mr. O'Donnell. Please subscribe to the channels, just one channel. And give me a thumbs up, like these series of videos, and give some comments. We need comments, okay? All right. And we're going to continue with these lessons on logarithms. Okay? See ya.